The Ultimate Factoring Series, Lesson 6b, Trinomials of the form ax squared plus bx plus c. In case you didn't watch Lesson 6a, these are all three the same. There's Lesson 6a, 6b, and 6c. Each of those lessons looks at the exact same problems, but it shows you how to do them using three different methods. So if you felt good about one of the other videos on this topic and you want to move on, feel free. If you feel like you want to see another option, then this would be a good video to watch. First example, 2x squared minus 11x plus 15. Since it's a trinomial, that means we have three terms. We know we're going to set it up this way. We're going to set it up with two sets of parentheses because we need to split this into a binomial and a binomial. Just like we did in lesson number 5 with just normal trinomials, we're going to put x and x out front. By the way, what's different about this lesson, in case it wasn't clear by the first title slide, what's different about lesson 6 and lesson 5 is in lesson 5 this was always just x squared out front. There was no other number. There's no coefficient in front of x squared other than just 1. So what makes lesson 6 different is we're going to have coefficients in front of x squared. So here's how we approach this. We have x and x in the front seats like we normally do in the front terms. And then the next step, here's something different from before, this is part of the bottoms up process, is you have to multiply the first times the last. So I have to multiply 2 times 15. So over here, instead of needing to multiply by 15, I need to multiply and equal 30. I still need to add up to negative 11 like I did before. So again, for bottoms up, you start by multiplying the first coefficient times the last number. 2 times 15 is 30. And you want something that multiplies to be 30 and adds up to negative 11. So let's talk about the factors of 30. That'll be 1 and 30, 2 and 15, 3 and 10, or 5 and 6. So let's see, to add up to a negative 11, we're going to have to use 5 and 6. And it's going to have to be a negative 5 and a negative 6. You can confirm that does add to negative 11 and multiply to be positive 30. So I put a negative 5 and a negative 6 in here. Now I'm not finished. If you stop here, it's a very wrong answer. But part of this is where the method bottoms up comes in. Since there was a number in front of the x squared, we now need to divide our two numbers by that number. So whatever number's right here, you need to divide both of these by. So 5 over 2 in the first term, that doesn't reduce at all. So what I have to do is take the bottom and move it up, meaning change this to 2x minus 5. Now over here, 6 divided by 2 does reduce. 6 divided by 2 works out evenly and just gives you 3. And that is bottoms up. You divide your two numbers by your a, whatever coefficient's in front of x squared. If you can't reduce, you move the bottom up. If you can reduce, then you're finished. If you FOIL this out, you'll find it works out to be exactly the same as what we started with, 2x squared minus 11x plus 15. Now that seems a little abstract. Bear with me for a few more examples and I think the pattern will make itself clear to you. So 4n squared plus 17n plus 15. So we know to set up two sets of parentheses since it's a trinomial. We're going to multiply 4 times 15. So we want to multiply to be 60 and add up to 17. So I list the terms that are going to be 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think that's all of them. And which of those will add up to 15, or excuse me, 17? Well, there's actually two, so we're going to have to see which one works as far as the signs are concerned. If I use 3 and 20, that would have to be a negative 3 and a positive 20. That doesn't multiply to be positive 60, which is what we need. So that's no good. So it's going to need to be 5 and 12. Because positive 5 and positive 12 equals positive 17. Positive 5 times positive 12 gives you 60. So I put the 5 and the 12 here, and then I look at this number, and I divide both of them by that number. Sorry, we do know those are positive. And here, 5 over 4 does not reduce, so I take the bottom and I move it up, giving me 4n plus 5. Here, 12 over 4 does reduce to just 3, and that is my final answer. Next example, 3r squared minus 16r minus 12. It's a trinomial. We need to set up the two parentheses to make it two binomials. I put r's out front, and then I multiply 3 times 12, so I need to multiply to equal 36. I need to add up to equal negative 16. So we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. All those multiply to be 36. The question is which ones will add up to 16. Well, it looks like 2 and 18 is the only option there. And to get a negative 16, we would need a positive 2 and a negative 18. Apologize, I should have written negative 36 there because it was 3 times negative 12. So that does work. 2 times negative 18 is negative 36, and 2 plus negative 18 is negative 16. So I put a positive 2 and a negative 16 here. Excuse me, negative 18. Very sorry, negative 18. So a positive 2 and a negative 18 go in. And now I have to look in front of my r squared, and I divide both numbers by that 3. So the 2 and the 3 don't reduce. So I take the 3, the bottom, and move it up. Bottoms up. 18 over 3 does reduce, and I just get 6. My final answer is 3r plus 2 times r minus 6. Okay, it's a trinomial. We set up two parentheses. We do 6 times 6, which is 36, so we need to multiply to be 36, and we need to add up to a negative 13. So come over here, 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. Let's see which ones will be 13. That'll have to be 4 and 9. And it'll be a negative 4 and a negative 9 to add up to a negative 13. And a negative 4 times negative 9 multiplies to be 36. So I forgot earlier, but remember you put a's out front. And then we put our numbers in, minus 4, minus 9. So we go in front here, and we need to divide both those numbers by 6. Okay, so this one's a little different from our first three examples because these fractions do reduce. 4 minus 6 will reduce to 2 over 3, and 9 minus 6 will reduce to 3 over 2. But we still have to do what this method is called, bottoms up. So we've reduced, which we needed to do, and now we move the bottoms up. So we get 3a minus 2 and 2a minus 3. Last example. 35m squared minus 22m plus 3 is a trinomial. So we set up our two parentheses, put m's in front, multiply 35 times 3. We need to multiply to be 105, and add up to negative 22. So 1 and 105, 3 and 35, 5 and 21, or 7 and 15. Those are all factors of 105. I had used my calculator earlier on this one, so for bigger numbers, if you have access to a calculator, please feel free to use that to kind of guess and check on what the terms would be that multiply up to it. So the only pair of those that will give me 22 when I add or subtract would be 7 and 15. So I need a negative 7 and a negative 15 to add up to a negative 22, And negative 7 times negative 15 multiplies to be a positive 105. So minus 7 and minus 15. So again, we go up front, we divide both of these by the number, the a, whatever's in front of m squared, and then we reduce if we can. 7 over 35 reduces to 1/7. See, 15 over 35 will reduce to 3 over 7. I need to correct this. I'm very sorry. 7 over 35 would be 1/5. 1/5. And then 15 over 35, yes, that should be correct now. So now that we've reduced, we do bottoms up. We take our bottoms and we move them up top. That leaves us with 5m minus 1 and 7m minus 3. And you can check your work here. 5m times 7m is 35m squared. Negative 3 times negative 1 is positive 3. So that is our final answer. So that's the bottoms up method. If you like it, feel free to just move on to lesson 7. If you feel like you need a different method, then please feel free to watch one of the other 2 videos on this.